Hi, and welcome to the video series on creating a DLX architecture simulator. Um, in the past videos, we were able to create a simple single cycle data path machine that will enter instructions manually into memory using binary, and they will be executed um, sequentially. So that was kind of like the first part of our roadmap, and that's where we were going to stop our first section. And now we're going to start on the second section where we implement a interpreter slash compiler to convert DLX assembly into binary, and then the binary file will be read into our simulator and into memory and then executed. So today we're going to start on that. I'm going to be writing it in C# because I'm already in Visual Studio. C# is really simple to do string parsing with. It's not the headache that C is. And it lets us to allows me to build out a user interface to make this both a compiler interpreter as well as an editor, and do kinds of stuff like that. So I'm going to do it in C#. I'm going to make sure that everything is abstracted away as possible. So if you're doing this in another language on another platform, you can do that. I'm just going to be doing it in C#. So to start with, I'm going to add a new project to my solution, and it's going to be a C# Windows Form application. Yeah, we'll make it a Windows Form application. We'll call it DLX editor. Alright, so that's created. So what we'll do is we'll go to our program, and I'm just going to comment out all the user interface based code, and now if I run this, it won't pop up user interface. It just exits. And that's because I want to abstract away the user interface part for now. I mean, I could actually leave it in and then just work around it, but we'll see what happens. So the first thing we're going to do is I am going to add a new item, and it's going to be a class, and we'll call it interpreter. Interpreter spelling. Alright, so inside the interpreter. So let's, I guess, add a, let's first, can we add a, okay, we can. So let's open up Notepad, and let's figure out what we actually want this to do. So the first thing we want it to do is we want it to read in DLX assembly, and then we want it to convert DLX assembly to binary, and then write binary to file. And we're going to need to support all of our DLX instructions, and we're also going to need to support some we'll call them pseudo instructions, and these are going to be things like halt, which will stop execution. We're going to need stuff like origin, which will say where to load file into memory. So for example, we could go orig 2000, and our script, or our source, would start at memory location 2000, And then we're going to do things like traps. And these are going to be like pre-written functions. We'll call them functions. And this is how we're going to do stuff like print out registers and all that kind of stuff. And what we're going to do is we're going to have so how we're going to do traps is we're going to say, okay, memory location 0 to 10 is going to be it's going to be our trap for, let's say, printing registers. So let's say print registers. So we'd say memory 0 through 10, and it would be like instructions like, let's say, add, blah blah blah, and then whatever. And then maybe it's like sub. But it would essentially be a way for us to actually, just to be accurate, it'd be more like move R7 to interrupt. Like we're gonna have to add things like interrupt registers to do traps. So that'll be like in the next section. But we're just kind of outlining all the requirements we're gonna need. So you'd say move like or set interrupt register. So it sets a 1 in there and says, hey, we're gonna be interrupting, and it sets a set interrupt code. The flag, and then that would go do its thing. Then we would say return R31, and then in the code we're writing, we would write trap x22, and then our interpreter would go, okay, trap x22. This gets converted to jump and link, I think it is. And then 0. So it would jump to 10, put the return value to 31, execute these instructions, then return to 31 and continue through our stuff. So it's just a way for us to handle this, and then inside of our simulator we'd have to handle stuff like this. And we can set up these special registers to do that. But that's kind of getting into the end of it. To start, we just want to do raw assembly. We will want to do the printing of registers and stuff to handle, like, we want to be able to test to make sure our simulator works. So instead of doing like a standard test-driven development where we put the testing in the C application in the simulator, we can put the testing into the assembly we write. So we can say, okay, set instruction or set register 10 to 30, print register 10, and then we can see if it actually equals what we want it to equal. So we can do all that kind of testing through the assembly, which is, I think it's better because we can see if we're getting what we want, and we can test all the instructions, and it's a little bit easier than trying to write the testing through the C application. So yeah, to start, we're just going to read in a file, we're going to convert the assembly to binary, and then write the binary to file. So in our interpreter, we're going to need an interpreter. We're going to need a class, we'll call it file handler. So the file handler is going to have in it a file. Oh, I haven't done C# in a little while here. File. No. Let's do a quick Google search here. C# open file. I think it's file dot. Yeah, it's file dot open. Using, there we go. Using system IO. And then we'll go string. Let's actually create a constructor here. So public file handler string path have a private string file location path equals, or file location equals path. And then what we'll do is we'll have a actually, let's do a file read. I want to read this one line at a time. So let's go private stream reader, file reader. So then we'll go file reader equals new stream reader, and then we'll say file location. And then what we'll do is write a public void. Actually, let's do a list of strings, and we'll call it read file. Let's actually change this to, actually that's fine, so read file, and we'll say list string lines equals new list, and then we'll return lines. So this is our file reader. It's really simple. It's just going to open the file, and then it's just going to read in each line and put it into a list. So we'll go for so we'll go while file.readLine, oh no, we can actually go for line or string line in, is that it? File reader read. Oh no, it's okay. I was using it wrong. So while file reader dot read line is not equal null. So that should work. I'm pretty sure. Lines dot add. Actually, we should go string cur line, and we'll go cur line equals file reader dot read line does not equal null, cur line. So there we go. That's nice and easy. It just reads the line in, adds it to a list of lines, and then it returns our list. So that's nice and easy. Now, the interpreter. Let's say it's gonna, so let's write another constructor, so public interpreter, we'll say takes in a list string of lines, and it's got private list string, and we'll say assembly lines, and I'll have another one, private list string. Actually, we'll say this is going to be a list of uint 32, and it's going to be binary lines. So this is the same as what a word is in our simulator. So we're going to create, so we'll say assembly lines equals lines, and then we'll write a public convert ASM to binary, and it's got to return, actually it can return int, and it's going to return a success code. So Um, Actually, let's write a little. So converts binary or assembly lines to binary, returns the number of lines converted. So we'll say int lines converted equals 0, return lines converted. So this way we can check to make sure all the lines were converted. And if it equals 0, which is the default value for false, we know it didn't work. So for now, what we'll do is we'll go for each string L in assembly lines console.writeLine L. So we'll just print out the lines for now. So now what we can do is we can go to program and we can comment these out. Oh, I just want to comment them out. There we go. What's the shortcut for that? Control K. And something else. Okay. So what we'll do is we'll go and we'll create an interpreter or a file handler. So file handler fh equals new file handler. And we'll say the path is the current directory. And then we'll go interpreter, or we'll go list string lines equals fh.readFile, and then we'll say interpreter I equals new interpreter lines I dot convert ASM to bin. Alright, so now if we go to, let's go to there's a way to open in open folder in File Explorer. Perfect. So let's create a new text document and we'll call it test. So open up with Notepad, sure. And we'll just write some lines in there. So we'll say line 1, line 2, line 3. So let's run this and we'll set our path to test.txt. And let's see what happens if we run it. I guess, yeah, it doesn't. So let's do console read key. Just to kind of get it to delay until we can. Alright, so it's not actually doing anything. Alright, so let's, I guess we can't just do that. Let's uncomment these. Oh, I'm not sure why it's not even launching this thing now. Let's see if we can just drag a button onto here. No, it's not even creating our. Let's see if there's any output. No, it's working fine. Oh, we're launching a simulator. Let's say build. Alright, so let's launch the right program then. Let's unpin this. Let's go back to program.cs. Let's copy these out. Or comment these out again. Fine. Comment. And save. And now let's. I want to run just this one. So debug let's see, can we? I want to. Alright, do a set it as startup project, I guess. File not found. Okay. So that's because we're looking in bin debug test.txt. So we want to go, so we're looking here, so we want to go up 2 directories. So we'll set it to up 2 directories. And now if we run it, so we can look here. It printed our 3 lines. So perfect. Alright. So let's close that. And I guess we can't really read from it, but where did we, oh, interpreter we printed, yeah, okay. So perfect. So now that we have that, let's say process line L. Let's write a private. Let's say, it's not called process. Handle line. So void handle line. Now what this function is going to do, string line, is it's going to actually determine what needs to be done. So we're going to have types of lines. We're going to have comments, ignore. We are going to have assembly instructions, and we're going to have non-assembly instructions. So we need to find out how we want to comment our code. I think x86 uses semicolons. We can use slashes. We can really do whatever we want. So I think that to kind of just be a standard with the way we do comments here, I'm just going to say that comments start with // So we can go if line 0 equals slash return. Actually, we should return an int. So we can go int status equals. So we should have a private. We'll just go. This is fine. What we'll do is we'll say status equals 0, and then we'll say return or status equals 1, and we'll say lines converted plus equals. So we'll do success. And then we'll return success. So yeah, if it's a comment, we don't care. And then if, actually we can go if it's a comment or line 0 equals a tab, or line actually let's convert this line. Let's go line dot replace, and we'll replace t is that the C# replace white space. There's some regex expression to do so I can replace all white space with by using system dot actually we just go regex regular, or maybe not, system dot text regular expressions dot regex replace. We can go line at s plus. I think that's the replace it with just nothing. So yeah, so it's going to take and find all the white space and replace with nothing. So it'll basically convert our line to just a plain text. So if we now console.write line we can look at that and see that's what it's going to look like. So let's open our output. Oh, it's not printing the. So let's do string new line equals line new line. So let's restart. So this is just using not the passed in values, so that it should get converted. Which it's still not, so that's not working. Why isn't that working? Let's try again. See if we can get rid of these spaces. No. Not sure why it's not removing the spaces. Oh, we'll just do this, then we'll do. I know this one works. We'll do new line. I should stop execution. Dot replace. And we'll do space with nothing. And then we'll do that. So that will replace the space in one. Okay, so we've got new line equals. There we go. So now let's remove the spaces. Oh. So let's stop. So we've stripped the spaces out of our line. So do we want to do that? Because we need a way to separate the registers from the instructions. So let's actually remove that for now. And let's go if. Yeah, let's go back to if new line, or let's go back to using line. If line 0 equals slash or line 0 equals slash new line. So we have to escape this. Then we want success to equal 1. Always have to be chars. Alright, there we go. Perfect. I thought it was the other slash for n for new line. But I guess it's not. So, if we now put into our test line 2, line 3, and we go to if we go to program.cs and we actually let's just do it at the end here, end of this one. Let's go print lines, print assembly. Oh no, that's not gonna work. Actually I will have to wait until after we have to add to binary lines. So I'm getting a little bit ahead of myself. So else, let's call success equals let's say convert binary, and we'll pass in line. So now we're going to have another function, private int convert binary string line, and we'll say int success equals 0, success equals a return success. So what this one's going to do is it's going to actually convert now. So in here we're going to need to basically have a giant dictionary. Yeah, we'll build it up here. We'll call it. Actually, we can actually add a new class, and we'll call it. Actually, let's see if we can add something else. Let's go add component. No, that's how you want. Let's go with interface. So I think in an interface we can do a dictionary string uint32, and we'll call it opcodes equals. Is that right? Interfaces cannot contain fields. Alright, so let's not make this an interface then. Let's delete the interface. And let's make it a class. Add class. And we'll call it. Oh no, there's two classes. Let's call it constants.cs. Let's go public dictionary, and we'll call it our string uint32 opcodes equals, and we'll have inside of it equals, I guess, a new dictionary, and then inside I think we have to go I think we use inside we use brackets as well, or braces. Yeah, so we go. So we would have we have to open up our instructions again. So we'll have because I'm trying to think how we're going to do the R type, where the opcode is 0, but it's got the, at the end, it's got the little so let's open this, and we need this. So let's just write out, yeah, let's just do bit manipulation on it. So we'll write out the entire operation. So we'll say string, we'll go beqz is going to be 0B, and then we need the opcode, so 1, 2, 3, 1, 1, 2, 3. So C# binary string, or binary literals. Okay, so you have to write them out in decimal. So what we'll do is we'll just do the opcode then. So 0x04. And then we'll have BNEZ 0x05. Add I. Sub I. I'm going to remove all these spaces, get really big. And the last one. So we have sub I, where we have 0x0a. We have and I, 0x0c. Or I, 0x0d. We have exclusive or I. We have 0x0e. Alright, so apparently I have to space these out. I can resharp that later and make it all consistent. So X or LHI is 0x0f. Then we have we did LHI, we have JR 0x12, JALR, which is 0x13. We have SLLI, which is 14. We have SRLI, which is 16. We have SRAI, which is 17. We have SEQI, which is 18. We have SNEI, which is 19. SLTI, which is 1A. We have SLEI, which is 1C. We have LW, which is 23. We have SW, which is 2B. We have J, which is 2. We have JAL, which is 3. So we can actually write these all out in decimal if we wanted to as well, but use the hex values because there's really no difference. So if you want to do this in the binary, you can. It's just until we get C#6, that's when they're adding support for binary values, or binary constants, binary literals to be exact. So if your language you're doing this in supports binary literals, feel free to use the binary, or if you want to use some other weird octal or anything else, you can use whatever you want. I'm just using the hex, so it keeps it short. So SRA 7, add 20 sub 22 and 24 or 25 exclusive or 26. These are actually all wrong. I'll have to switch them out in a second. CQ. I'll switch these out already. These are all zeros actually, because the opcode is 0. SLT. And then SLE 0. So this one, I guess from set, that's the first one. 0, 0, 0, 0. So these are all 0, 0 because the opcode is 0, and then the function code is what these values are. So I should actually specify that in my other document as well. So I will correct that next. So there we go. We have our dictionary with our subsystems. So now what we can do is in our interpreter, we can first of all go line or string. We can say new line equals line dot to lowercase or to lower. If we have any weird uppercase letters in there, it doesn't matter. And then we can say uint 32 instruction equals. So let's go. Let's say let's minimize DLX sim. Let's go constants dot oops. So let's go private constants constant vowels equals new constants. And then we can go, actually switch names to C. We can go equals C dot opcodes, and we want the key, which is going to be, oh, we should actually first of all string split equals new line dot split on white space. I think even if we have a tab in there, it'll still work. Yes. Right. So string and string split options dot remove empty entries. Perfect. Now, why does it still give me an error? Cannot convert from string to char. Cannot convert Okay, let's remove that. And now it's not letting me. Oh, this has to be a string or an array. I think it goes after this string syntactically. Yeah, I think that's right. Okay, perfect. That was a bit labored. So let's go uint32 opcode equals split or c dot opcodes and then split 0. So that'll get the opcode from there and then put success. So now if we go print opcode or console dot write line opcode. Now if we breakpoint here, we change test to say add blah, and then we can do like beqz blah, and we can go sub 1 2 3 4 blah. We can save it, and if we start, we should get the opcodes, which should be 0, 4, and 0. So we got 0. Oh, we shouldn't have closed test.txt. Let's open it up. So we should have 0, 4, 0. So if we continue, we have 4, or we have 0. Perfect. So we can go, so we got the opcode, and now we need to shift the opcode by 26. So now if we print the opcode, it should be a really big number. Well, actually, it'll still be 0 there. The next one should be a really big one. Yeah, and then 0. Perfect. So the reason the other ones are 0 is because they're zeroed out. So now, what we need to do is we need to opcode and equals, we'll say get process instruction or process arguments, and we'll say split 1, and then we'll write that function as well, private uint32 process arguments, and we'll say last string args, and what we'll do is we will return 10 for now, and we'll make sure that that works. Actually, let's console dot write line /t plus args, and this is just going to be to make sure that we get this line as returning that for the second value. So 1 2 3 1 2 3 4 1 2 3 4, perfect. And zero. Oh, this should be or equals. Because if we AND it, it'll just set it to 0. So, because we want them to equal 10. Yeah, so the next one should be a really big number. And, okay, so that one didn't return the string because it's not splitting on. So you want to split on white space. So C# split on white space. Um, so we can do apparently if we do null, it'll split on white space. So let's try restarting and see what we get. Um, so apparently that's not going to work. So let's see if we can um, using come on system.text.regular expressions. So now we can go regex dot split new line at s plus where s, so this is a link expression. Oh, that's just gonna, actually we don't need that, 'cause that's just gonna say where it's not null, or it's not empty. But if it's empty line, we already get rid of it. So that should now split. Oh wait, stop. We need to put it somewhere. So we should find out what it returns. Regex dot split returns a string array. Perfect. String split. So now if we do it again, let's actually put a breakpoint here. And let's continue, continue, continue. And if we look at split, oh, perfect. So now it removed all white space. Perfect. So that's what we want. So regex is saving the day. Oh. So there we go. Now what we've done is we've split it on the value, and we've So we've split it on white space, which means we'll remove these. And now what we want to do is we want to string args no white space equals regex dot replace, and we want input to be args, pattern to be white space, we want to replace it to be nothing. And then we want to string args equals split, or args no white space. Actually, we should change this name to, actually let's call this line. Call this line, and then args equals args no white space dot split on comma. This can be a character, not a string. And then so this is just going to say remove the white space again, replace it with nothing, and then split that on comma, so we can do add R1, R2, R3, R1, R2, and R1, R2, R3. So let's run this test now, and let's put a breakpoint at return 0, and make sure this is doing what we want it to do. So we should actually put a breakpoint here. Let's restart. So we can remove all these, clear all, and let's watch args NWS, and let's watch args. So let's step over. This equals R1, which we don't want it to do. And this is R1. We can do, what's it here? String split options dot removed empty entries. Let's stop this. So we want string split options dot remove empty entries. Cannot convert from string split options to, well, we don't want it to. No. I don't want you to change it to a char. Why are you trying to change it to a char? That's not gonna work. Let's go here, let's go system. Oh, what is it? String split options. SI or ops equals string split options dot remove empty entries. Ops. Still trying to convert to a char. Well, then let's go char separators equals new char one and separators 0 equals. Is that gonna work? There we go. Alright, so that was a little bit convoluted, but we did it. Now we can do so what is regex.replace returning? Why is it not? What did we use up here? We used how did we do it before? Let's try string args nws equals line dot replace space with nothing. Yeah, it's not gonna work. Remove white space. Yeah, sorry, this should have worked. Don't know why it didn't. Oh, forgot to put a breakpoint in. Let's try this again. Oh, aha. It's splitting all the lines. Oh, that's right. I forgot about that. So what we want to do is we want to combine for each s. Let's go split dot. Can we remove? Select. Oh yeah. Okay, fine. Let's go string args equals args equals null string for int I equals 0, I is less than. Actually, no, we need a way to do this. I'll have to recombine them. Actually, what if we go opcode equals, and then we go line dot replace, and we go split 0 with empty string. Haha. So now, let's make sure this worked. But we should be passing in, yes, so line equals the remainder. Perfect. So now, args equals R1, R2, R3. And args equals R1, R2, R3. Just like that. Whew, there we go. So that was a little bit convoluted, but that's the fun of string processing. So just to reiterate, what we've done is we open a file and we read each line into our into a list, and we return that list. That list then gets passed to our interpreter, which will convert from assembly to binary by ignoring lines that start with a comment or a new line, and the rest of them will then get their opcode converted to a hexadecimal value, and the remaining portion of the line will be converted to a binary value, which will then be ORed into the opcode the opcode would then be written to binary lines dot add, and we'll go. Actually, we should call this bin. Actually, let's call it instruction. And then we'll add instruction. And then we'll write a private or public list uint32 binary lines get return binary lines. So that's just a way to, it's just a public accessor to binary lines, so we can get the binary lines. And then we can have a public void write lines, write file, string path, and we'll say list actually these will be uint32's instructions. And then we'll go file, actually we'll go private stream writer, file writer equals new stream writer, path, so path, and then we'll go for each uint32 I in instructions file writer dot write line. Actually, we just want to write I. We don't want to put new line characters in there. And then file writer dot close. And we'll close this one too. Actually, let's put that in here. Open our file reader here, and then reader dot close. Oh, I don't want to do any of that. There we are. So that is going to be it for this video, since it's running kind of long. But we have set up our file reading and writing. We've set up our don't read any of these. So we've set up our file reading and writing. We've written an interpreter that starts converting our line from plain text to binary, and that is almost all of our converter. So in the next video we'll finish it up, and then we'll write the reading of the binary file into the simulator and do that. So until next time, happy programming.